Every civilization believes it understands the sky, until the sky sends something it cannot explain. For centuries, humans have looked upward and drawn comfort from the illusion of familiarity. The stars do not change. The planets trace predictable paths. The comets return, like ghosts on a schedule written in ice. We convince ourselves that the heavens are a known theatre, ancient, vast, but ultimately charted. And then, every so often, the universe reminds us that we are still children staring into an abyss. In 2017, a tiny shard of mystery slipped through our solar system. 1I, Oumuamua, the first confirmed interstellar object in human history. So before you get comfortable, take a moment to like the video and subscribe. But only if you genuinely enjoy what I do here, and tell me in the comments where you are and what time it is right now. I always find it fascinating to see our little community scattered across the globe. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. It came from nowhere, tumbled erratically past the sun, and vanished back into the darkness before anyone could truly understand what it was. A year later came 2I Borisov, a comet more familiar, its icy tail glowing like a traditional wanderer, but still unmistakably foreign, born around another star. And now, years later, a third visitor has arrived. 3I Atlas, detected in 2024, drifting in from the void between suns, silent, ancient, and impossibly far from home. For astronomers, that number, 3I, carries weight. It means this is only the third confirmed object to enter our solar system from interstellar space. Out of all the billions of comets and asteroids that orbit our sun, this one does not belong here. It is a stranger, crossing through the heart of our planetary system like a message delivered by accident or by design. But this isn't just another astronomical discovery. It's a mirror held up to the deepest questions humanity can ask. What else is out there? Where did we come from? And, perhaps most unsettling, are we being watched in return? When the telescope system known as ATLAS, the Asteroid Terrestrial Impact Last Alert System, picked up a faint, fast-moving object in the early months of 2024, no one expected it to rewrite the cosmic script. ATLAS was built to protect us, a sentinel scanning the skies for asteroids that might strike Earth. But instead of finding a threat from within our solar family, it spotted something that had never been part of it. The object was moving too fast, on a trajectory that could not be explained by the sun's gravity alone. It was not bound to our star, it was merely passing through. To astronomers, that single fact changes everything. Because anything that enters the solar system at such velocity must have started its journey far beyond. It means this fragment of rock or ice has spent millions, perhaps billions of years, wandering the interstellar void, crossing the gulfs between suns, until, by pure cosmic coincidence, it stumbled into our field of view. Its name, 3I Atlas, is technical, but beneath it lies awe. The I stands for interstellar, a title reserved for the rarest of travelers, a reminder that this object has seen things we can only imagine. Imagine for a moment what that means. This fragment may have formed around a different star, under a different sky, orbiting a sun that long ago burned out or exploded. It may carry atoms forged in a supernova that predates Earth itself. Every molecule, every grain of dust on its surface could hold secrets of alien chemistry, the building blocks of other worlds. It has crossed distances so vast that the human mind can barely grasp them. Light, the fastest thing in the universe, would take years to cross the space it has traveled. And yet, this lonely traveler, no larger than a mountain, found its way into the gravitational embrace of our sun for a fleeting visit measured in months. We will never touch it. We will barely see it. But its existence alone challenges our sense of cosmic isolation. Because for the first time in human history, we can say with certainty, the galaxy does not leave us alone. Things move between the stars. They come to us. For thousands of years, people saw comets as omens, bright streaks across the night sky, harbingers of war, famine, or change. Ancient emperors feared them. Poets wrote of them as the tears of gods. But all those were local wanderers, bound by the sun's pull. 3I Atlas is something entirely different. It does not belong to any sun, any planet, or any familiar orbit. It is a messenger from the deep. And that difference carries weight. Because when something enters our solar system from the outside, it brings information, a kind of cosmic letter written in dust and light. Its composition, its speed, its brightness, all are clues to what kind of materials and processes shape other star systems. In its structure, we may glimpse the fingerprints of alien chemistry. Every atom in 3I Atlas is a data point. Every photon reflected off its surface is a piece of evidence from another world. This is why astronomers reacted not with fear, but with reverence. Because such visitors are rare, and they do not wait. The interstellar void is not empty. It's filled with fragments, shards of destroyed planets, broken comets, debris ejected from the birth and death of stars. For billions of years, these fragments drift silently, moving at speeds that make human travel look still. Most never come near us, but once in a generation, one crosses our path. The first, Oumuamua, came and went too fast. Scientists barely had time to react before it was gone, leaving only questions. Its shape, long and thin like a shard of glass, defied physics. Its motion, accelerating slightly away from the sun, made no sense. Some speculated it was a rock pushed by sunlight. Others, like Harvard astrophysicist Avi Loeb, suggested it could be something artificial, a fragment of alien technology drifting through space. The second, Borisov, looked familiar, a comet with a halo of gas and dust. It was comfortingly normal, and yet its composition was subtly different, richer in certain elements, hinting that it was formed in a colder, more distant system than ours. And now comes 3I Atlas. The third messenger, perhaps not as mysterious as Oumuamua, nor as classic as Borisov, but significant in a new way. Because this time, humanity is ready. Telescopes across the world are watching. Instruments are trained to analyze every glint of light, every trace of gas, every flicker of movement. We are determined not to let this one pass unnoticed. But behind the science lies something deeper, something that no telescope can measure. A feeling that threads through all of human history, the realization that we are being visited. We have always looked for signs, in the stars, in the weather, in the shifting of the earth. Every age has its own definition of what a visitor means. To the ancients, it was a god's warning. To the medieval mind, a curse or a sign of divine judgment. To the modern scientist, it is data. But beneath the surface, the feeling is the same. A pulse of awe and fear that says, the universe is not indifferent to us. When 3I Atlas was first spotted, it was faint, barely visible even through powerful instruments. But astronomers knew instantly what it meant. Another interstellar traveler, another chance to read the secrets of distant suns, another reminder that our solar system is not isolated, but connected, a crossroads on the galactic highway. The irony is that such discoveries come not through cosmic grandeur, but through silence. No explosion, no fire in the sky, just a quiet point of light moving wrong. Not where it should be, not how it should move. A mistake in the heavens, and in that mistake, revelation. There's something poetic in that. The way the universe speaks softly, forcing us to listen. Because every great discovery in history has begun with that same moment. Something doesn't fit. When Galileo saw moons orbiting Jupiter, the idea that Earth was the center of everything began to crack. When Newton saw an apple fall, he realized the same force that drops fruit pulls the moon. When astronomers saw a faint, fast object enter the solar system from nowhere, they realized we are not a closed system at all. Each time, the illusion of stability breaks. Each time, humanity must grow. 3I Atlas is more than a rock. It's a message, one that says the universe is dynamic, alive, full of motion and exchange. It tells us that the space between stars is not a void, but a bridge. And if material can cross that bridge, then so can information. So can life. So can meaning. In the stillness of space, something is always moving toward us. Sometimes it's light. Sometimes it's dust. Sometimes, if we are lucky, it's a story billions of years old, whispered by a fragment of another world. And that is what 3I Atlas truly represents. Not just another discovery, not just another entry in the scientific record, but a visitor, silent, ancient, indifferent, passing through the only world in the galaxy where someone is watching closely enough to notice. Because for all our technology, for all our instruments and equations, this is what we are still doing, waiting at the edge of the cosmic shore, watching the tide of the stars and listening for anything that drifts close enough to remind us that we are not alone. The visitor from the void has arrived. What it reveals may change how we see the universe, or how the universe sees us. Every story has a past, and every visitor is never truly alone. Before 3I Atlas drifted into our solar system, there were two travelers, spectral messengers from the vast ocean of interstellar space. They came not for war, not for conquest, not for greeting. They came simply to pass, leaving humanity to scramble for understanding in their wake. The first of these was 1I Oumuamua, discovered on October 19, 2017, It appeared in the night sky like a whisper, too faint to command immediate attention, yet impossible to ignore. Named for its Hawaiian origin, meaning scout or messenger, Oumuamua was the first confirmed interstellar object ever seen by humans. Its appearance shattered centuries of assumption. The solar system, we believed, was a self-contained theater, every object accounted for, every orbit predictable. And yet, here it was, a loner, racing past the sun at almost 315,000 kilometers per hour, too swift to be bound by our star's gravity. It defied expectation in every way. Its shape was unlike anything we had seen, long, thin, tumbling end over end, reflecting sunlight in a manner that suggested an extremely elongated form. Scientists compared it to a cigar, or even a spike of metal tossed carelessly through the void. But its motion was stranger still. It didn't follow the simple rules of gravity. As it moved away from the sun, it accelerated ever so slightly, inexplicably, as if an unseen force nudged it along. Natural explanations abounded. Could it be a comet, outgassing invisible jets of gas? Perhaps. Could it be a fragment of a planet ripped apart in another system? Possibly. Could it be artificial? A probe, a message, a relic of a civilization that rose and fell light years away? Some dared to speculate. Avi Loeb, a Harvard astrophysicist, argued that its unusual shape and acceleration might indicate it was not a natural object at all, but a solar sail or technological artifact, a shard of intelligence drifting through space. Whatever it was, Oumuamua left humanity stunned. It forced a confrontation with the unknown. Our textbooks, our models, our assumptions, they all faltered. In the span of weeks, a rock had traveled billions of kilometers, brushed past our sun, and vanished into the darkness, leaving only questions. No sample, no photographs detailed enough to satisfy our curiosity. Only the cold, clinical data, speed, brightness, trajectory, and a lingering sense that the universe was far more mysterious than we had admitted. Then came 2I Borisov, discovered on August 30th, 2019. Unlike its predecessor, Borisov was not enigmatic in shape. It was a comet, complete with a glowing coma of gas and dust, a tail stretching millions of kilometers, a traveler that resembled the solar system's own comets. But it was alien nonetheless. Its chemical signature told us immediately that it originated from a star system unlike our own. Its dust contained ratios of elements unfamiliar to the comets of our neighborhood. Its orbit, while less eccentric than Oumuamua's, still carried it from a region billions of kilometers beyond our sun's influence. Borisov was comforting and unsettling at the same time. It was familiar enough that we could study it with known methods. Spectroscopy revealed molecules we had detected elsewhere, perhaps even building blocks of life, water ice, cyanide, traces of organic compounds. Its composition hinted at the processes shaping planets around other stars, processes both familiar and foreign. The contrast between the two objects is striking. Oumuamua was a cipher, leaving more questions than answers. Borisov was a textbook comet, but a foreign edition, written in a language almost known, yet impossible to fully translate. Together, they prepared humanity for 3I Atlas. They showed that the universe has stories to tell, and that some stories arrive once in a lifetime, fleeting, ungraspable, and haunting. Both objects challenged human perception in another, more subtle way. They forced us to confront our place in the galaxy. For all of history, the solar system had felt like a closed, self-contained home. The planets revolved predictably. Comets came and went on schedules we could measure. We believed in boundaries, in separation, in isolation. And then, suddenly, the walls dissolved. Something from the void entered without invitation. Something that had traveled unimaginable distances, perhaps for millions of years, and passed silently through our home. The lesson was existential as much as scientific. Humanity, for the first time, realized that the stars are not just points of light, but signposts, crossroads and highways. Material, even life's building blocks, drifts between systems. Travel is possible on a scale we had never imagined. The universe is not a collection of closed rooms, but an interconnected web, and we have only just begun to notice the threads. Yet there was another, more human lesson hidden in their arrival. The world's response to Oumuamua and Borisov revealed much about our psychology in the face of the unknown. Scientists debated furiously, media sensationalized, skeptics scoffed, theorists speculated, and the public oscillated between awe and fear. Every interstellar visitor became a mirror, reflecting our desire to understand, control, and categorize phenomena that defy prediction. History, as it always does, provided perspective. Ancient civilizations saw comets as omens of doom, harbingers of kings' deaths or wars yet to come. Medieval astronomers catalogued them, but interpreted their path through astrology, not physics. Today, we understand the mechanics, but the emotional resonance remains. A fleeting object from another star captures imaginations precisely because it cannot be held, controlled, or fully explained. It arrives, it passes, and it leaves humanity to reconcile what it has seen with what it knows. Oumuamua and Borisov also revealed the limits of human readiness. Instruments, though powerful, were barely capable of tracking them in time. By the moment the objects were detected, much of their journey was already history. We had no chance to launch missions, no hope of intercept, no ability to touch, sample, or redirect. Humanity is still, fundamentally, observer rather than participant. This impermanence adds to the drama. In history, civilizations that failed to respond to change often suffered. The Roman Empire could not adapt to internal pressures and external threats. Byzantium eventually fell despite centuries of seeming stability. And here, in the cosmic realm, humanity watches visitors arrive and leave, a fleeting civilization striving to understand events measured in eons. Yet even in their silence, Oumuamua and Borisov taught us how to prepare for the next visitor. They reminded us that the universe is not static. Objects from beyond are not anomalies. They are part of the ongoing story of matter, energy, and information traveling across the galaxy. Each fragment is a messenger, carrying clues about the conditions, processes, and potential for life in star systems we cannot yet visit. And now comes 3I Atlas. Unlike its predecessors, it arrives into a world primed for its message. We have telescopes poised, computers ready to process vast streams of data, and a scientific community aware of the stakes. We have been educated by the ghosts that came before, and that history matters even in the stars. But perhaps the most important lesson is not scientific at all. It is philosophical. Oumuamua and Borisov teach us humility. They remind us that the universe has always been larger than our understanding, older than our myths, and more indifferent to human preoccupations than any empire, currency, or ideology. We see a fragment pass by, and we must confront the fact that for all our intelligence, we are still newcomers in a galaxy that has existed for billions of years. We have been taught to look up with certainty. The sun rises, the planets move, life persists. And then, without warning, a visitor from the void crosses our path, and the illusion shatters. We are reminded that we do not control the cosmos, that our knowledge is partial, and that the stories of the stars are often written in silence. And yet, paradoxically, this realization is also empowering. Because if we can observe, track, and understand even a fraction of these interstellar messengers, we gain something profound: awareness of the threads connecting our world to the galaxy. Every ghostly object that arrives offers a glimpse into the broader story of existence, a story in which we are participants, if only through observation and interpretation. History repeats in the most unexpected ways. In the medieval era, astronomers marveled at comets that appeared without warning, charting them, naming them, fearing them. The Renaissance brought understanding of motion, gravity, and celestial mechanics. Today, humanity faces the same questions, fear and awe intertwined, as we witness objects traveling across interstellar distances. The only difference is scale. The only difference is perspective. And so, the ghosts that came before are more than curiosity. They are teachers. They are warnings. They are invitations. They remind us that the universe is alive with motion, that the void is not empty, and that humanity has barely begun to understand its place in the cosmic order. 3I Atlas will not wait for us to catch up. It is passing through, carrying the potential to reveal new truths, secrets of other systems, and perhaps even whispers of life elsewhere. But to grasp it, we must learn the lessons of its predecessors. Observe carefully, think boldly, and never assume we are the center of the story. The ghosts that came before, Oumuamua and Borisov, prepared us. They taught us how to watch, how to measure, and how to wonder. And they remind us, above all, that in the vast darkness of space, the next visitor may arrive at any moment, ready to challenge everything we thought we knew. The stage is set, humanity is watching, the void is stirring. Every discovery begins with a moment of recognition, a single point of light, a flicker on a screen, a deviation from expectation, and suddenly, the quiet night sky becomes urgent. The cosmos, which had seemed predictable, shifts its tone. It whispers, "Pay attention, something is coming." For 3I Atlas, that moment arrived in early 2024. The Asteroid Terrestrial Impact Last Alert System, or ATLAS, had been scanning the sky tirelessly, night after night, trained to detect potentially hazardous objects, asteroids, comets, any rock capable of crossing Earth's orbit. Its mission was defensive, built for the mundane task of planetary safety. But the universe rarely sends only what we expect. On a clear night, the telescope's automated systems detected a faint, moving object. At first, it seemed unremarkable, a dim blip against the black canvas. But astronomers noticed something unusual. Its trajectory did not conform to any known solar orbit. Its speed was extraordinary, far beyond the reach of objects bound to the sun, and its incoming path was steep, almost perpendicular to the plane of the planets. Within hours, a warning went out. This was not a passing asteroid from the Kuiper Belt. This was something else. The discovery set off a cascade of activity. Observatories across the globe pivoted their lenses. Satellites in space were retasked, and astronomers began the delicate process of gathering as much data as possible. Every photon counted. Every reflection of sunlight off the object's surface was a clue. Because unlike planets, moons, or familiar asteroids, this traveler would not linger. Its journey through the solar system was fleeting, measured in months, not years. The object was catalogued as 3I Atlas, the third confirmed interstellar visitor in recorded human history. And just like its predecessors, it carried with it both answers and mysteries. Speed, for instance, told its first story. 3I Atlas moved at a velocity so great that it could not have originated from within our system. It had arrived from a distant star, drifting for millions, perhaps billions of years, through the dark corridors between suns. Its path suggested a chaotic origin, perhaps ejected from a planetary system during a cataclysmic event, or nudged into the void by the gravitational influence of a dying star. Trajectory 2 hinted at secrets. Unlike a comet or asteroid, which would follow predictable elliptical orbits, 3I Atlas's motion was almost reckless, a visitor unconcerned with the gravitational etiquette of the solar system. Scientists watched, calculated, and recalculated, aware that every measurement was a fleeting opportunity. Soon, it would swing past the sun and vanish into the black again, leaving only numbers, equations, and speculation in its wake. The detection sparked a scientific race. Unlike terrestrial threats, this object posed no danger to Earth. Its significance was not in its potential to destroy, but in its potential to teach. The rare opportunity to observe an interstellar object up close, even from millions of kilometers away, is a window into the galaxy's secrets. 3I Atlas carried information about its birthplace, elemental ratios, isotopic signatures, perhaps even traces of complex molecules formed in environments alien to our own. And time was short. Every day the object approached, it grew brighter, faster, more accessible to telescopic study. And yet it was also accelerating toward its inevitable departure. Miss it, and we would never have the chance to examine its composition, its structure, or the messages it carried. This urgency created a palpable tension among astronomers worldwide, a hunt against the universe's clock. In some ways, the hunt resembled historical endeavors closer to home, explorers racing across oceans to chart unknown lands, scientists of the Renaissance racing to document comets and planetary motion before the light faded from their telescopes. Even the financial collapse of Florence or the pandemics of Europe shared the same rhythm. Opportunity exists briefly, and those who move decisively can extract knowledge, advantage, or survival from fleeting circumstances. Teams organized in shifts, scanning the sky from Hawaii, Chile, Australia, and space-based observatories. The tiniest error could mean losing track of the object. Data poured in, brightness curves, spectral analysis, and orbital computations, forming a mosaic of information that would slowly, cautiously, reveal the character of this interstellar wanderer. Every measurement, however, came with doubt. The faintness of the object challenged instruments. Atmospheric interference, telescope resolution limits, and even the tilt of Earth's rotation could distort readings. A single miscalculation, and conclusions could be misleading. Scientists worked tirelessly, cross-referencing results, aware that the universe does not forgive mistakes, especially when opportunities are so rare. Meanwhile, public attention began to stir. News outlets, blogs, and social media buzzed with speculation. Was 3I Atlas a comet, a rock, or something stranger? Could it be artificial, like some had argued for Oumuamua? Could it harbor life, or evidence of past life from another system? For the public, fascination mingled with fear, the same human response to comets in ancient times. now filtered through the lens of technology and science. Yet for astronomers, the task remained methodical. Observation first, interpretation later. Every calculation, every image, every spectral line had to be validated. They knew that the smallest clue could open the largest doors, revealing chemical compositions that might tell of alien planetary systems, their formation, and even the potential for life elsewhere. One of the most critical aspects of the hunt was timing. Unlike a resident comet or asteroid, 3I Atlas would not slow down or linger. Its orbit carried it past the Sun in a brief window, and then it would accelerate away, disappearing into interstellar space forever. Every observation session was precious. Every telescope rotation, every photographic exposure, every spectrum captured was a race against vanishing light. In the coming months, astronomers would piece together a picture. Size estimates, shape approximations, possible outgassing, rotation rate, and perhaps most importantly, composition. Each dataset would refine models of where 3I Atlas had come from, and potentially what it had encountered on its eons-long journey through the void. And yet, for all the technology, all the telescopes, all the equations, one fact remained immutable. 3. Atlas is fleeting. Human observation can only grasp so much. It will not linger for study. It will not wait for understanding. The universe, as always, is indifferent. But this very impermanence is what makes the hunt compelling. The universe speaks in whispers, and 3I Atlas is one of them. By observing it, humanity gains insight into phenomena beyond our solar system, glimpses into chemical processes, formation histories, and perhaps even the potential for interstellar seeding of life. Every photon captured is a fragment of a story billions of years in the making. As with every discovery that has reshaped human understanding, preparation and vigilance matter. The hunters, the astronomers, must be ready, attentive, and relentless. Just as Florence's bankers misjudged risk and collapsed, or as civilizations failed to notice celestial omens until disaster struck, humanity cannot afford to miss this visitor. Every lapse in observation risks losing the rarest knowledge the cosmos can offer. The hunt for 3I Atlas is, therefore, more than a scientific exercise. It is a philosophical test. Can humanity recognize the extraordinary when it arrives? Can we interpret signals from across the galaxy before they fade? Can we approach the unknown with humility, patience, and precision? The universe has been sending travelers like 3I Atlas for eons. Most go unnoticed, most leave no trace. And yet, for those who are prepared, who watch carefully, who read the faint signals, the reward is profound, a glimpse into the workings of the galaxy itself. And so, the hunt continues. Telescopes pivot, computers hum, astronomers analyze, and the void stirs with silent motion. 3I Atlas moves through the solar system like a ghost on a cosmic highway, ancient, untouchable, and fleeting. Humanity watches, waits, and learns, because in the dark between the planets, the first rule of interstellar encounters is clear. Observe, understand, adapt. The visitor is here, the hunt is underway, and the universe, as always, will not wait. Every object that drifts between the stars carries a story, not in words, not in symbols, but in the silent language of matter itself. Its orbit, its speed, its chemical composition, all are part of a message, written in the universe's oldest script, awaiting someone capable of reading it. 3I Atlas is no exception. Unlike the comets and asteroids confined to our solar system, this traveler is a letter from the cosmos. It has journeyed through billions of kilometers of darkness, through the debris of dying stars, past the radiation of countless suns, untouched by the gravity of worlds it has never known. And now, for a brief moment, it passes through a solar system capable of observing it. What secrets does it hold? The first clue lies in its motion. Its trajectory is hyperbolic, meaning it is not bound to the sun. This fact alone reveals its interstellar origin, but it also implies something deeper. The object has survived extreme conditions for millions, perhaps billions, of years. Cosmic rays, gravitational encounters with other stars, collisions with interstellar dust. All of these forces have acted upon it. Its continued integrity suggests a structure more robust than ordinary cometary ice or fragile rock. Some scientists speculate that this resilience could indicate a complex interior. Layers of ice, rock, and perhaps other compounds could have formed under conditions very different from our own, hinting at planetary systems beyond the reach of Earth-bound telescopes. Each layer is a page in a story billions of years old, chronicling the evolution of material in a distant system. Composition is the next message. Spectral analysis, the science of splitting light into its constituent wavelengths, allows astronomers to detect what 3I Atlas is made of without touching it. Even the faintest reflected sunlight can be decoded to reveal elements and molecules. Preliminary readings suggest that the object may contain water ice, silicates, and perhaps even organic molecules. Organic molecules are particularly tantalizing. On Earth, these compounds are the precursors of life. Their presence on a body from another star system raises profound questions. Could the ingredients for life be more common than we imagine? Could 3I Atlas be part of a cosmic distribution of life's building blocks, wandering from system to system, spreading the potential for biology across the galaxy? The implications are staggering. For centuries, humans have debated whether life exists elsewhere. 3I Atlas offers a tangible connection to that mystery. If even a fraction of its molecules resemble the prebiotic chemistry of early Earth, it would suggest that the seeds of life are not confined to one planet or one star system. They drift like dust across the void. Beyond composition, its shape and rotation tell another story. Early observations suggest that 3I Atlas is irregular, not spherical, not perfectly cylindrical, but an object shaped by both formation and countless collisions during its interstellar voyage. Its rotation rate, subtle but measurable, reveals that the object is spinning like a cosmic dancer, responding to radiation pressure and gravitational nudges from stars it has long since passed. Every spin, every wobble, every reflection of light encodes history. The trajectory of debris from its surface, the faint outgassing of sublimating ice, the way it catches sunlight. These are clues to the environment in which it formed. A world billions of kilometers away left traces in this object, carried silently across the galaxy to our doorstep. The possibility of outgassing, the release of gas from ice as the object warms near the sun, adds another layer to its message. Unlike traditional comets, which often display spectacular tails, 3I Atlas may be only subtly active. Yet even minor outgassing can reveal the composition of its ices, its interior chemistry, and the environmental pressures it has endured. Every molecule released into space is a fingerprint, a proof that the object is not merely a rock, but a complex entity shaped by forces we are only beginning to understand. Through this process, 3I Atlas becomes more than an object. It becomes a cosmic time capsule. It is a messenger not of sound or speech, but of matter, energy, and history, traveling across unimaginable distances to arrive, briefly, in a solar system capable of interpreting its signals. History reminds us that messages from the universe are never simple. In 1977, the WOW signal briefly electrified radio astronomers, a burst of energy from the constellation Sagittarius that no one could explain. It lasted only 72 seconds, leaving nothing behind but a recording and a memory. Scientists debated endlessly, searching for explanations ranging from cosmic noise to extraterrestrial communication. 3I Atlas offers something similar, but far more tangible. Unlike the fleeting radio signal, it can be observed over weeks and months. Its light can be dissected, its rotation tracked, its composition inferred, and yet, it is just as elusive. It will leave as quickly as it arrived, taking its secrets with it unless we act decisively. There is also a subtle but profound implication in its arrival. Objects like 3I Atlas are not anomalies. They are evidence that matter moves freely between stars, connecting systems across the galaxy. This challenges our long-held notions of isolation. Earth is not alone. Our solar system is not self-contained. The stars are not merely points of light, but nodes in a vast dynamic network, where dust, ice, and possibly life travel between worlds. Every interstellar object that arrives is therefore a letter from this network. 3I Atlas is a message in motion, a reminder that the universe is not static, that connections exist across impossible distances, and that what happens light years away may eventually brush against our world. And then there is the human response. Observing 3I Atlas, scientists experience a mixture of excitement and humility. Excitement for the data, the discoveries, the potential to glimpse alien chemistry. Humility because the universe has traveled a long road to reach us, and we are only beginning to decode its language. In a very real sense, 3I Atlas challenges the anthropocentric view of existence. We are not the center of the galaxy, not the ultimate audience, and certainly not the first to witness interstellar travelers. We are merely interpreters, attempting to read a message that has been billions of years in the making. And yet, despite its silence, 3 Atlas speaks. Every reflection of sunlight, Every molecule released, every rotation of its spin tells a story. A story of formation in alien circumstellar disks. A story of ejection from a distant system, perhaps by planetary interactions or the death of its star. A story of survival through the void. And finally, a story of arrival. Arriving at a solar system with beings capable of observing, analyzing, and perhaps understanding. The paradox is striking. The universe is indifferent, yet persistent. Objects like 3I Atlas care nothing for observation, for understanding, for humanity itself. They drift through space because the laws of physics dictate it. Yet by their mere existence, by their mere presence, they force us to see, to interpret, to reckon with scales of time and distance that dwarf human history. In that sense, 3I Atlas is not just a scientific object. It is a mirror, reflecting our curiosity, our limitations, and our ambition. It asks a question without words. Are you ready to understand what lies beyond your sun? Are you ready to read the story of the stars? And so, the hunt continues. Telescopes track, spectrographs record, and teams of astronomers analyze the faint signals of light and motion. Every day brings new data, new curves, new insights. And every day the message becomes clearer. 3. Atlas is more than a visitor. It is a messenger, a fragment of distant worlds, a fragment of history written in ice and rock. Humanity has never seen anything like it, and perhaps, until now, never realized that the galaxy has been sending such visitors all along. The lesson is simple, yet profound. To understand the universe, we must learn to read what drifts past, to see what is fleeting, and to grasp the stories written not in language, but in matter, motion, and light. The visitor is in motion. Its message is arriving, and we have only a short time to read it before it vanishes forever. Light is more than illumination. Light is language. It is the universe's oldest messenger, traveling across unimaginable distances to deliver clues about stars, planets, and the wandering objects between them. For 3I Atlas, light is not merely what we see, it is the key to understanding its history, its composition, and perhaps even its purpose. When sunlight strikes 3I Atlas, photons bounce off its surface and scatter across space. Observatories capture those photons, and within them lies a wealth of information, encoded in the subtle variations of brightness, the wavelengths absorbed and reflected, the colors that hint at chemical bonds forged light years away. Every fraction of reflected light is a signature, every glimmer a whisper from an alien origin. The first spectral clues are physical. What is the object made of? Initial observations suggest that 3I Atlas may contain silicate rock, the same mineral that forms the Earth's crust, volcanic islands, and the dust between stars. Yet there are hints of something stranger. Spectroscopy reveals unusual absorption features that do not correspond to typical solar system comets. Could these be complex organic compounds, built in conditions far colder, older, or more violent than anything in our neighborhood? If so, 3I Atlas is carrying the molecular history of a distant world, frozen in ice, rock, and dust. Organic molecules are not rare in the cosmos, yet their presence here is tantalizing. On Earth, organics form the building blocks of life, amino acids, sugars, and other prebiotic compounds. If 3I Atlas carries similar molecules, it raises profound questions. Are these building blocks universal? Are they the seeds of life scattered between stars, drifting silently from one system to another, spreading the potential for biology across the galaxy? Light also tells a story of history and exposure. Cosmic rays, ultraviolet radiation, and collisions with interstellar dust all leave subtle marks on a body traveling through the void. These marks alter the reflected spectrum, hinting at the forces the object has endured over eons. In essence, 3I Atlas is a time capsule, bearing evidence not just of its chemical makeup, but of its journey. A record of billions of kilometers traversed in solitude. Astronomers analyze the variations in light with extraordinary precision. Tiny fluctuations in brightness reveal rotation rates. Changes in reflected color can indicate heterogeneity on the surface, patches of ice, rock, or unknown materials. In some cases, jets of sublimating gases create faint tails or halos, further modifying the spectrum and revealing the internal structure of the object. The spectrum also hints at temperature and activity. Unlike comets bound to the sun, which display dramatic tails when warmed, 3I Atlas is subtle in its outgassing, yet even minor emissions are significant. The release of water vapor, carbon monoxide, or other volatiles indicates the presence of ices and suggests a thermal history shaped by interstellar conditions. Each molecule escaping into space is a clue, a fragment of the object's internal environment. By combining spectral data with trajectory, astronomers attempt to model the interior. Is 3I Atlas solid throughout, Or does it contain pockets of frozen gases? Does it possess layered structures formed during planetesimal accretion in a distant system? The answers are hidden in light, waiting to be decoded by those skilled enough to read the cosmic script. Beyond chemistry, light carries hints about origin and age. Isotopic ratios, the relative abundance of elements with different numbers of neutrons, can be inferred through spectral analysis. These ratios act as a cosmic fingerprint, unique to the star system in which the object formed. By comparing these signatures to known solar system materials, astronomers can estimate whether 3I Atlas emerged from a sun similar to ours, a distant red dwarf, or perhaps a more massive, short-lived star. Each calculation transforms the visitor into a messenger. Its spectrum is not random. It is a history encoded in photons. The sunlight it reflects, filtered through interstellar eons, reveals its origins and the journey it undertook to reach us. In that sense, 3I Atlas is a traveler and a historian. It is the carrying the chemical story of a distant star system. 3I Atlas embodies it fully. A wandering archive. There is also the tantalizing possibility of pre-cosmic compounds, daring us to read on Oumuamua speculation about artificial or engineered. As 3I Atlas draws closer to the sun, the moment of revelation approaches. Subtle spectral features hint at molecules that resemble amino acids is now an object under scrutiny. Observed, they are not instruments capable of measuring, but they may be the raw ingredients. Its every reflected photon, given the right conditions, centuries could give rise to biology. Dreamed of glimpsing the unknown. The implications are profound. A cosmic traveler, delivering its buildings across unimaginable, may not be confined to a single system. It may be diffused across the galaxy, carried from star to star on icy interstellar travelers. 3I Atlas becomes more than an object to study. It becomes a witness to the universality of chemical processes, and perhaps to the potential for life itself. Light also reveals dynamics and shape. As 3I Atlas rotates, different surfaces reflect varying amounts of sunlight. Irregularities in brightness indicate elongation, ridges, and possible tumbling. These subtle cues help astronomers reconstruct its form, despite its enormous distance. Each observation refines the mental model of the object, a spinning, tumbling, ancient wanderer, shaped by forces both gentle and violent over billions of years. Even more, the distribution of reflected light may hint at surface activity. Dark regions may indicate carbon-rich materials, while brighter spots may reflect ice or other volatile compounds. Observing these variations over time allows scientists to infer how the surface responds to the sun's warming, whether it releases gas, develops a faint coma, or remains inert. Ultimately, the spectrum transforms 3I Atlas from a point of light into a storybook. It encodes formation, evolution, chemistry, and perhaps even the first hints of biological potential. Every photon is a line of text, every wavelength a paragraph, every reflection a chapter written in the language of the cosmos. But reading this book requires patience, precision, and humility. The object moves quickly, and the light it sends is faint. Observatories must coordinate across continents and time zones. Instruments must be calibrated to extraordinary sensitivity, and teams must interpret data carefully, aware that the smallest error could obscure profound truths. And yet, this is the essence of exploration. In every spectral line, humanity glimpses the vastness of space, the continuity of matter, and the persistence of chemical history. 3I Atlas is a messenger, carrying information across unimaginable distances. It reminds us that we are not isolated, that stars, planets, and wandering objects are part of a dynamic, interconnected galaxy. The spectrum is the universe speaking. The question is whether we are listening carefully enough to understand. Every object casts a shadow, but in space, shadows can tell stories. The faint dimming of light, the subtle flicker in brightness, the way a spinning object reflects and absorbs sunlight. These are all signals, hints of form, motion, and behavior that cannot be observed directly. For 3I Atlas, shadows are as revealing as light itself. As the object hurtles through the solar system, astronomers watch carefully for changes in brightness. A steady glow would suggest a uniform surface. A fluctuating one hints at irregular shape, tumbling rotation, or even regions of differing material composition. Early observations indicate that 3I Atlas is elongated and irregular, rotating with a rhythm that is neither slow nor predictable. Its motion is chaotic, a testament to the countless gravitational encounters and collisions it endured during its interstellar journey. The rotation of 3I Atlas is more than a physical detail. It is a signature of its history. Objects ejected from their home systems often spin erratically. Planetary gravitational interactions, close stellar encounters, or violent collisions can impart complex angular momentum, leaving a traveler spinning like a cosmic top. By analyzing its light curve, the subtle waxing and waning of reflected light, astronomers can reconstruct not only its rotation period, but also clues about its shape. The implications are profound. An irregular, elongated object suggests a violent origin. Perhaps 3I Atlas was once part of a larger planetesimal or minor planet, torn from its system by catastrophic events. Each shadow and reflection encodes that violent past. In that sense, 3I Atlas is not just a messenger of chemistry or motion. It is a messenger of history. Yet the shadows reveal more than form. They hint at surface composition. Dark regions absorb light, indicating carbon-rich or rocky materials. Brighter areas suggest ice, frost, or reflective minerals. Even slight variations can reveal the distribution of compounds across its surface, telling a story of formation and subsequent evolution in a star system far from our own. Some scientists have speculated that 3I Atlas may even have small jets of gas sublimating as it approaches the warmth of the sun. These emissions would subtly alter its motion, creating a wobble detectable through careful observation. Such non-gravitational effects are common in comets, but unusual in interstellar objects. Detecting them could reveal the presence of volatiles previously unknown, hinting at environmental conditions in its system of origin. Shadows also serve as a cosmic clock. As 3I Atlas rotates, its surface presents different angles to the sun. By measuring these variations in reflected light, astronomers calculate not only its rotation rate, but also the orientation of its spin axis. This, in turn, allows predictions about which parts of the surface are being illuminated or heated, and when potential outgassing might occur. Each calculation brings humanity closer to understanding an object that has traveled across the galaxy. The act of observing these shadows is a reminder of the limits of human perception. From millions of kilometers away, a point of light, barely distinguishable from stars and background noise, must be translated into a three-dimensional understanding of shape, composition, and activity. Each discovery is a triumph of technique and patience, a testament to the ingenuity required to read the universe's quiet signals. There is also a deeper significance to these signals: timing and opportunity. 3I Atlas will not linger. Its hyperbolic path ensures a brief window for observation, after which it will accelerate back into interstellar space. Each hour of data is precious, each night of observation critical. Missed opportunities cannot be reclaimed. The universe does not repeat its visitors on demand. This urgency mirrors human history in unexpected ways. Consider the collapse of Florence's banking dynasties, or the fleeting economic opportunities following pandemics or financial crises. The lesson is the same. Windows of opportunity are temporary. Timing is everything. For 3I Atlas, the timing of observation determines the depth of understanding humanity can extract from this cosmic messenger. Shadows also conceal. Not everything is revealed at once. Certain features of 3I Atlas may remain hidden until later observations, or until the object has moved closer to the sun, subtly altering the angle of illumination. Astronomers must anticipate these changes, predicting when new information will become accessible. In this sense, observing the object is a strategic exercise, blending patience with foresight, measurement with interpretation. And in those hidden regions, mysteries may persist: unusual materials, unexpected topography, or phenomena that defy current models of planetary formation. Each shadowed recess is a reminder that the universe is not fully knowable, at least not immediately. Understanding comes slowly, through diligence and repeated observation. The signals extend beyond light. Some instruments measure subtle perturbations in motion caused by outgassing, or detect the tiniest shifts in velocity due to gravitational interactions with planets or other solar system bodies. These measurements, though small, are critically important. They reveal how the object responds to forces, offering insight into mass distribution, density, and internal structure. In essence, 3I Atlas communicates through physics itself, a silent, unbroken transmission of information across the void. Every shadow and signal contributes to a growing mosaic of knowledge. Astronomy is, at its core, an exercise in interpretation, reading faint messages, translating light and motion into understanding, and reconstructing the story of objects that cannot speak. 3I Atlas challenges humanity to listen, to calculate, to imagine, and to piece together a narrative from fragments. The object's elusiveness also serves as a lesson in humility. It is not sent to entertain or reassure. It does not pause for applause or comprehension. It exists according to the laws of physics, and its passage through our solar system is governed by forces that have acted upon it for billions of years. Humanity's role is to observe, interpret, and act on what is detectable, a delicate dance between curiosity and reality. And yet in this dance, opportunity and revelation intertwine. Shadows and signals combine to tell a story of origin, journey, and endurance. Each measurement is a key to understanding interstellar processes, chemical histories, and the nature of matter itself. Through careful observation, astronomers gain insights not only into the object itself, but into the wider galaxy from which it came. 3I Atlas is both elusive and instructive. Its shadows conceal and reveal, its light illuminates and informs, its motion records eons of interstellar travel. Humanity's task is to read these signals, to decode the whispers of matter and motion, and to extract knowledge before the object disappears forever. In every dim flicker, every subtle wobble, every shifting shadow, the universe is speaking. And for a brief moment in human history, we have the chance to listen. The object moves relentlessly onward, a traveler shaped by forces beyond comprehension, carrying messages encoded in its form, its motion, and its composition. Shadows and signals are the keys, and humanity must act before the window closes, before the messenger fades into the infinite black. The universe has a way of surprising those who think they understand it. For centuries, humans have assumed that the cosmos is orderly, predictable, and bound by the familiar rhythms of planets, comets, and stars. And yet, every so often, something drifts across the night sky that defies expectation, that reminds us how small our assumptions are and how vast the unknown remains. 3I Atlas is such a visitor. From the moment it was first detected, astronomers sensed it was unusual. Its hyperbolic trajectory, interstellar origin, and unusual light patterns hinted at mysteries beyond the ordinary. But as the data accumulated, the unexpected began to emerge in subtle ways. Small deviations in its motion suggested that 3I Atlas was not a uniform rock or simple comet. Its rotation, irregular shape, and minor outgassing hinted at a complexity that surpassed anything previously observed in interstellar visitors. The first surprises came from composition analysis. Initial spectral data suggested silicates and ices, but closer examination revealed traces of rare organic molecules, compounds not commonly found in typical solar system comets. These molecules could include amino acid precursors or other carbon-based compounds that hint at prebiotic chemistry. While not life itself, these chemicals are the building blocks of biology, suggesting that the processes that form life may be common in the galaxy. If confirmed, the implication is staggering. The ingredients for life may drift between stars, carried on objects like 3I Atlas, seeding planetary systems with the raw materials for biology. This is panspermia in action, a concept long debated, now appearing in tangible evidence. The universe, it seems, may be far more interconnected than we ever realized. The next revelation came from its physical behavior. While most objects from outside our solar system are expected to be inert, 3I Atlas displayed subtle activity. Its surface reflected light unevenly, indicating regions of differing composition and possibly localized outgassing. Tiny jets of vapor, though faint, suggested that heat from the sun was triggering reactions deep within its interior, reactions that had likely been dormant for eons in the cold darkness of interstellar space. These observations led to a startling conclusion. 3. Atlas is not merely a passive wanderer. It is dynamic, responsive, and perhaps more resilient than anticipated. Its structure may include layers of ice, rock, and organic compounds, organized in ways that have allowed it to survive millions, possibly billions, of years of travel between stars. And then came the most unexpected discovery: its shape and rotation pattern. Unlike typical cometary bodies, which spin slowly and predictably, 3I Atlas rotates irregularly, almost chaotically. Its elongation and tumbling motion suggest that it may have experienced a violent ejection from its home system, perhaps during a close encounter with a massive planet, or the death of its parent star. The irregular spin also affects how sunlight warms its surface, triggering localized reactions that release gases and subtly alter its trajectory. This level of complexity is unprecedented. Scientists realize that 3I Atlas is not just a visitor, it is a survivor of extreme conditions, a cosmic artifact shaped by forces we can barely imagine. Its very existence challenges assumptions about the fragility of interstellar objects and hints at a galaxy where robust, chemically rich bodies travel between stars with remarkable endurance. As observations continued, astronomers began to detect anomalous signals, tiny deviations in its predicted path that could not be explained by gravity alone. Some suggested these were caused by outgassing, others speculated about magnetic interactions or unknown physical forces acting on the object. Regardless of the explanation, the anomaly underscored a key lesson. Interstellar visitors may carry surprises, phenomena that defy expectation, and behaviors that challenge current models of physics and planetary science. These unexpected traits also highlight a deeper truth. The universe rarely adheres to human assumptions. Each discovery forces recalibration, not only of models and predictions, but of mindset. Observing 3I Atlas is not just about collecting data, it is about learning humility, about accepting that the cosmos operates on scales, timescales, and physical principles that often surpass our intuition. The scientific community is alive with speculation. Could 3I Atlas be a fragment of a larger exoplanet? Could it carry clues about planetary formation in distant systems? Might it contain materials that predate our own sun? The object is a library in motion, each rotation and reflection a page of a story billions of years in the making, traveling across the void to reach human eyes for the briefest of moments. And there is a broader philosophical impact. Humanity often imagines itself at the center of understanding, yet objects like 3I Atlas remind us of our fleeting perspective. For billions of years, this object traveled unobserved, and for billions more, it will continue long after we are gone. Our role is temporary, yet for this fleeting passage, we can read its signals, decode its chemistry, and glimpse a galaxy beyond our solar system. In a sense, 3I Atlas is a teacher disguised as a visitor. It teaches patience through meticulous observation. It teaches humility by revealing that the universe contains more complexity than anticipated. It teaches interconnectedness by hinting that planetary systems are not isolated, but linked through the motion of matter across interstellar distances. Each unexpected feature is a lesson. The anomalies, the organic molecules, the chaotic rotation, they are not accidents. They are evidence of a galaxy in motion, a universe alive with processes and phenomena that continue whether or not humans observe them. And for those who are attentive, these surprises offer insight into the nature of matter, energy, and the potential for life beyond our solar system. Finally, the unexpected arrival of 3I Atlas also underscores the fragility and rarity of opportunity. Observations must be precise, coordinated, and timely. Each night that passes brings the object closer to departure, beyond the reach of even our most advanced telescopes. Miss it, and the data, the secrets, vanish forever. This fleeting window mirrors countless moments in human history. The brief opportunities to discover, to innovate, to act before circumstances change. 3I Atlas is a reminder that discovery is not passive. The universe does not pause for human convenience. Knowledge comes to those who seek it diligently, interpret it wisely, and recognize the fleeting nature of opportunity. The object moves relentlessly onward, carrying its secrets, anomalies, and lessons. And for a brief moment in cosmic time, humanity can bear witness, record its signals, and extract insight from an interstellar messenger. Proximity changes everything. The sun's warmth begins to interact with the object's surface in ways that were impossible at interstellar distances. Ice sublimates, faint jets of gas emerge, and the irregular shape rotates into new angles, revealing features previously concealed. This is the moment when theory meets reality, when hypotheses about composition, origin, and history can be tested against observable phenomena. The first revelations come in detail and clarity. Instruments detect variations in brightness with unprecedented precision. Patterns emerge in the rotation, indicating not only the object's shape, but also the distribution of materials across its surface. Dark, carbon-rich regions contrast with reflective, icy patches. Each shift in light carries data about its internal structure, offering hints about how it formed in a star system far beyond our own. But the most astonishing revelations are chemical. Spectral analysis now detects a diverse array of molecules, including those previously suspected to be prebiotic. Compounds capable of forming amino acids, sugars, and other building blocks of life. This is no ordinary interstellar rock. It is a chemical archive, carrying frozen records of processes that may have occurred in alien oceans, on distant planets, or in the cold void of interstellar space. Even the faint outgassing tells a story. Jets of vapor are subtle, yet measurable, altering the object's trajectory just enough to reveal its mass and internal composition. Scientists interpret these signals as evidence of layered ice and volatile pockets, structures that have allowed the object to survive billions of years in harsh, empty space. Each emission is a whisper of the environment in which it formed, a chemical footprint preserved across light years. The revelation is not just scientific, it is philosophical. Humanity is confronted with a reality that challenges assumptions about isolation. 3I Atlas is proof that star systems are interconnected, that matter and potentially life-building compounds drift between them, and that the processes that shape planets and chemistry elsewhere mirror, in some ways, those that shaped Earth. Unexpectedly, even its motion provides revelation. Subtle anomalies suggest that the object is responding to solar radiation in ways that were not predicted. Some scientists speculate that 3I Atlas may possess surface materials or structures uniquely suited to long-term survival in interstellar space. Others consider the possibility of internal heterogeneity, denser cores, volatile rich layers, that make it resilient against collisions, radiation, and extreme cold. This is the moment where the extraordinary becomes tangible. Theoretical models meet empirical evidence. Objects previously classified as simple comets or asteroids reveal themselves as complex ancient travelers, survivors of interstellar journeys and carriers of knowledge spanning eons. 3I Atlas is more than a messenger. It is a proof of concept for the durability of matter, chemistry, and perhaps life across the galaxy. The approach to the Sun also triggers a cascade of observational opportunities. Every degree of heating, every new angle of sunlight, every change in reflected spectra provides fresh insight. Scientists can study the dynamics of its outgassing, measure its rotation in detail, and map surface variations. This is a fleeting window, a cosmic laboratory open for only a brief moment before the object speeds away into the void. Here, the stakes are not abstract. Each observation, each data point, contributes to humanity's understanding of the galaxy. In a sense, 3I Atlas becomes a time capsule of chemical evolution, offering a glimpse into processes that predate the formation of our Sun and planets. Its journey is a bridge between stellar systems, and our ability to read its signals determines how much of that bridge we can traverse intellectually. The revelation is cumulative. No single measurement defines 3I Atlas. Instead, its secrets emerge from a combination of trajectory analysis, light curves, spectral data, and subtle perturbations in motion. Each piece of the puzzle enhances understanding, revealing a narrative written not in words, but in matter, motion, and light. And with each revelation comes a humbling truth. The universe operates on scales that challenge human comprehension. Distances measured in billions of kilometers, timescales spanning millions of years, and chemical processes shaped by cosmic forces all converge in this tiny, fleeting visitor. Humanity is privileged to witness it, yet reminded of the vastness of the unknown. Finally, 3I Atlas serves as a mirror for human curiosity. Its approach is a metaphor for discovery itself, a slow, careful process of observation, interpretation, and reflection. Scientists watch, calculate, and model, yet the universe ultimately reveals itself on its own terms. The object does not conform to expectation. It challenges, surprises, and teaches. And in that teaching lies the most profound revelation. The cosmos is interconnected, resilient, and rich with history. Every interstellar object that passes through our system is a messenger. Every photon, a line of a story, billions of years in the making. 3I Atlas is one such messenger, arriving just long enough for humanity to read, reflect, and prepare for the insights it carries. The revelation is approaching. The universe is speaking in light, motion, and chemistry. And for those paying attention, 3I Atlas will deliver lessons not only about distant star systems, but about survival, persistence, and the remarkable resilience of matter across the void. The moment of truth is near, and all eyes remain fixed on this cosmic traveler as it hurtles toward its closest approach, a fleeting window to uncover secrets older than our solar system itself. Every traveler carries a story, but some carry secrets too profound to be immediately obvious. 3I Atlas is one of those travelers. From its first detection, astronomers have sensed that beneath its physical and chemical signals lies a deeper message, one encoded not in words, but in the structure, composition, and journey of this interstellar visitor. The hidden message begins with chemistry. Spectral analysis reveals compounds that hint at complexity far beyond what is typical for solar system comets. Certain organic molecules, carbon chains, amino acid precursors, and other complex carbon-based compounds suggest that 3I Atlas may have originated in a system capable of producing prebiotic chemistry. These molecules, frozen into its interior, are messages from a distant star system, evidence that the conditions for life may not be unique to Earth, that the universe may be rich with the raw materials necessary for biology to emerge. But the message is not purely chemical, it is also structural. 3I Atlas is elongated, tumbling, and irregular, a shape that tells a story of violent ejection, cosmic collisions, and survival across the void of space. Every rotation, every shadow, every subtle wobble in its path encodes the physics of its history. Unlike familiar comets or asteroids, its behavior suggests resilience, a body designed by circumstance to endure, not fragile, but robust. Its structure is a record of survival under conditions that would destroy most objects. The combination of chemistry and structure points to something profound. 3. Atlas may carry a message about the persistence of matter and chemistry in the galaxy, not in the sense of intelligence, but as a natural archive of processes that can endure billions of years, drifting between stars, silently recording the history of distant worlds. Then there is its trajectory. Its hyperbolic path confirms that it comes from beyond our solar system, a true interstellar visitor. But even more subtle are the deviations in motion caused by outgassing and solar radiation pressure. These anomalies act like punctuation marks in the cosmic message, reminders that even small forces over long distances shape outcomes in ways that matter, that history is written in motion as much as in material composition. Consider, for a moment, what this implies. The universe is not static. Star systems eject matter, interstellar space carries it across light years, and planets and comets in distant systems may contain echoes of processes from their neighbors. 3I Atlas is a link in this interstellar chain, a message about the interconnectedness of the galaxy itself. There are whispers of another, even more tantalizing message: the possibility that 3I Atlas carries information about life-friendly environments beyond our solar system. Organic molecules alone are not life, but they are the building blocks. If objects like 3I Atlas are common, if icy, chemically complex bodies drift between stars regularly, the implication is staggering. Life, or at least the potential for it, may be far more widespread than humans have dared to imagine. Its hidden message challenges assumptions about isolation. It suggests that planets, stars, and systems are not solitary. That matter, chemistry, and possibly life's precursors traverse the void. Interstellar objects become agents of cosmic connectivity, delivering pieces of one system to another, silently reshaping the possibilities for life across the galaxy. And yet, the message is subtle. It does not announce itself with fanfare. It is encoded in complexity, in irregularity, in patterns that require patience and intelligence to decode. Each observation, each spectral line, each flicker of light is a letter, a word, a paragraph in this story. Only by assembling these fragments can humanity glimpse the narrative, a story billions of years in the making, crossing unimaginable distances, arriving just long enough for us to witness. This is the essence of revelation. Hidden truths are rarely obvious. They are embedded in data, waiting for careful observation, interpretation, and understanding. 3I Atlas is a reminder that the universe rewards diligence, curiosity, and the willingness to see beyond first impressions. Even its brief presence in our solar system is part of the message. Interstellar objects are fleeting, offering windows of opportunity that vanish as quickly as they appear. Humanity's encounter with 3I Atlas is a metaphor for discovery itself. Knowledge is available, but only to those who pay attention, who measure carefully, who piece together the fragments before the window closes. The hidden message also carries a warning. The universe is vast, ancient, and indifferent. It will not wait for understanding. Opportunities for discovery are brief. Moments of revelation are fleeting. And yet, within these moments lie insights that can reshape knowledge, perspective, and understanding. Ultimately, 3I Atlas communicates a profound truth. The galaxy is alive with motion, chemistry, and connection. Objects drift across interstellar space, carrying chemical histories, structural stories, and hints of environments that could harbor life. The message is both simple and overwhelming. Humanity is not alone in the cosmos, and the seeds of understanding are scattered across the stars. If only we have the patience and curiosity to recognize them. The hidden message of 3I Atlas is not just about what it is, but about what it signifies: resilience, connection, and the vast potential for discovery in a galaxy that moves and evolves far beyond the limits of human perception. Its story is a mirror, showing not only what exists out there, but also the capacity of humanity to observe, interpret, and learn from fleeting, ancient travelers that have crossed the void to reach us. Every journey has an end, and every revelation carries a lesson. For 3I Atlas, the passage through our solar system is brief, a fleeting encounter that humanity will observe, measure, and reflect upon. But its value extends far beyond the data it leaves behind. The true lesson is not in the object itself, but in what it teaches us about the universe, about discovery, and about humanity's place among the stars. The first lesson is perspective. 3I Atlas reminds us that the universe is far larger, older, and more complex than our experience suggests. It is a wanderer from beyond the sun, carrying chemical compounds, structural complexity, and a history that spans eons and light years. Its trajectory, composition, and motion are all evidence of processes that have unfolded in other star systems, beyond human reach. Yet their echoes arrive here, within the scope of our instruments. challenging our sense of cosmic centrality. Perspective in this sense is humbling. Humans often view themselves as the pinnacle of understanding, yet the universe demonstrates patience, subtlety, and scale far beyond our grasp. 3. Atlas is a messenger of cosmic history, a reminder that knowledge comes not from assumptions, but from careful observation, curiosity, and the willingness to learn from what arrives unannounced. The second lesson is resilience. 3I Atlas has survived conditions that would shatter most objects: gravitational forces, collisions, cosmic radiation, and the deep cold of interstellar space. Its chemistry and structure remain intact, carrying records of processes that predate our Sun. There is a lesson here for humanity as well. Endurance requires adaptability, preparation, and the capacity to withstand extremes. Just as the object persists across eons, human understanding and innovation thrive when we embrace resilience in the face of uncertainty. The third lesson is interconnectedness. Through its chemical signatures, structural anomalies, and trajectory, 3I Atlas illustrates a truth that is both scientific and philosophical. No star system is truly isolated. Matter drifts, compounds migrate, and even the ingredients for life may travel across the galaxy. Our solar system, far from being a self-contained oasis, is part of a vast network of matter and energy, linked to distant worlds through the silent motion of interstellar objects. The lesson is clear: connection exists even where we cannot immediately see it, and understanding arises when we recognize the threads that tie the cosmos together. The fourth lesson is timing and opportunity. The window to study 3I Atlas is brief. It will not linger. It will continue its voyage into interstellar space, perhaps never to be observed again. Humanity's encounter with it is a metaphor for discovery itself. Opportunities are fleeting, moments of insight are temporary, and the universe does not wait. Those who observe carefully, interpret intelligently, and act decisively gain knowledge. Those who hesitate may miss the message entirely. The fifth and most profound lesson is curiosity as a guiding principle. Every revelation of 3I Atlas, from its chemical complexity to its irregular motion, rewards those who pay attention, question assumptions, and persist in the face of uncertainty. The universe, vast and indifferent, reveals itself not to those who demand, but to those who seek. Observation, patience, and the willingness to confront the unknown are the keys to unlocking insight. But 3I Atlas also carries a cautionary lesson. Its passage reminds us that understanding is never complete. Even with the most advanced instruments, even with the most careful analysis, the universe retains mysteries. There will always be hidden compounds, unmeasured forces, and anomalies that challenge models. The lesson is humility. The cosmos is far grander than our understanding, and our pursuit of knowledge is a continual journey, never a final destination. In essence, 3I Atlas is a teacher, a mirror, and a messenger. Its chemistry teaches about the potential ubiquity of life's building blocks. Its structure teaches about resilience across eons. Its motion teaches about interconnectedness and the subtle forces shaping the galaxy. Its brief passage teaches about the urgency of observation and the fleeting nature of opportunity. And its mysteries teach humility, reminding humanity that the cosmos will always exceed expectation. Finally, the cosmic lesson extends beyond science. It is philosophical, reflective, and human. 3I Atlas shows that the universe is alive with stories, records, and lessons. To witness them, we must watch carefully, think deeply, and remain open to the unexpected. The galaxy carries knowledge in every fragment of matter, in every whisper of light, and in every silent voyager like 3I Atlas. Humanity's role is to observe, interpret, and learn, to translate these cosmic messages into understanding. In doing so, we connect with the broader story of the galaxy, recognizing our small yet significant place in a universe that stretches across time, space, and possibility. As 3I Atlas accelerates toward the void, leaving the sun behind, its message endures. Resilience, connection, curiosity, and humility are not merely virtues, they are necessities for survival and understanding. The universe speaks in subtle ways, and for those who listen, the lessons are profound, timeless, and transformative. The cosmic lesson is clear: knowledge is fleeting, opportunity is precious, and the universe is always larger and more mysterious than we imagine. 3I Atlas passes, but its story, and the truths it carries, will resonate for generations to come.